So in this question it's given that a train starts from rest and moves with a constant acceleration, that's 2.0 meter per second square, and it's given that the train moves for 30 seconds. It's given half a minute, we can see it in the screen. So after that it's given that the brakes are then applied and the train comes to rest in 1 minute. We have to find the total distance moved by the train. Okay, acceleration is acceleration, that is 2 meter per second square. Okay, acceleration is 2 meter per second square. Acceleration is 2 meter per second square. All right, 2 meter per second square, and it's given that the train moves for half a minute. So by using the formula, s is equals to ut, s is equals to ut plus half at square, we know that s is equals to ut plus half at square, the formula. Here the u is 0 because the train initially is at rest, so u represents initial velocity in here, so this part becomes 0, and here we have half into acceleration is given 2, acceleration is 2, it is given in here, see 2 meter per second square, and for half a minute that's 30 seconds, that's 30 square 900, and these two and these two gets cancelled, and from here we get that 900 meters. Okay, from here we get 900 meters. Okay, this is 900 meters. Okay, let it be s1, let this be s1, this distance let it be s1. Okay, after that what is given, the brakes are then applied. Okay, the train has covered a distance of 900 meters in the first 30 seconds, so it would have been attained a velocity in these 30 seconds, it would have attained a velocity. Okay, so let us find that one. For velocity we have to use the formula v is equals to u plus at, v is equals to u plus at, v is equals to u plus at. Wait, let me write perfectly, this is plus. Okay, this represents plus, v is equals to u plus at, so u is 0 here because the train was initially at rest, plus acceleration is 2 and multiplied by 30 because the train has ran for 30 seconds. From here we get the velocity, which comes to be 60 meter per second. So the train has attained a velocity of 60 meter per second in the first 30 seconds. Okay, so after that it is given that the brakes are then applied and the train comes to rest. When the brakes are applied, the train will produce a deceleration. Okay, so again we have to write the formula. V is equals to u plus at, v is equals to u plus at to find out the deceleration. See, here it's given the brakes are then applied and the train comes to rest in 1 minute. The train comes to rest, that means velocity has been 0, the final velocity has come to 0, and initial after 30 seconds the velocity attained by the train is 60 meter per second. So here initial velocity is 60 plus a into time, how much time it's given in the question. The brakes are then applied and the train comes to rest in 1 minute. That's 60 seconds. From the acceleration comes to be minus 1 meter per second square. So the deceleration is minus 1 meter per second square. Okay, after that was given deceleration. Okay, So we have to find the time after the brake, find the distance after the brakes are being applied, the train has ran. The train means as soon as the brakes are applied, the train will not come to rest. It will travel a certain distance, and after that it will come to rest. Okay, so it's given that the train comes to rest in 1 minute. So for that 1 minute, the train must have means covered a certain distance. So we have to find that one. Let's give the name h2 to that distance, is equals to, again using the formula, ut plus half at square. Okay, ut here is 60, initial velocity 60. See, the train comes to rest in 1 minute, that means 60 seconds. That means 60 seconds plus half. The deceleration produced is minus 1 meter per second square, minus 1, and it will come to rest in 1 minute, that's 60 seconds. 60 square. Okay, from here we get 60 into 60, that's coming to be 3600, and here half into minus 1 minus half into 3600, that's 3600 by 2, that's coming to be 1800. That's coming to be 1800. Let's keep this in bracket, and it's in meters distance. Okay, so here it's coming to be, wait, let me write perfectly, 1800 meters. So h2 is 1800 meters. Okay, then summing up the total distance covered by the train in the entire 30 and 60 seconds, total distance moved by the train, the total distance moved by the train. Now we have to find out that one. Okay, total distance moved by the train. Okay, total distance moved by the train, moved by the train equals to s1 plus s2, that's equals to 1800 plus 900. 1800 plus 900, wait, 1800 plus 900, that's equals to 2700 meters, that's equivalent to 2.7 kilometers. Okay, first part we have found out the first part, the total distance moved by the train. Okay, and then the second part, the maximum speed attained by the train, that's 60 meter per second. Here we have found out that one too. The maximum speed, it's 60 meter per second. And what is given in the third part, let me see, the position of the train at half the maximum speed. Half the maximum speed, what's the maximum speed? That's 60 meter per second. Half of that maximum speed will come to 30 meter per second. Okay, wait, let us do that. Maximum speed, Vmax is 60 meter per second. Okay, they are asking that when the V is half of Vmax, that is equivalent to 30, 60 divided by 2, 30 meter per second. When it is this much, when the velocity is 30 meter per second, then how much distance the train would have actually covered? Okay, so again we have to put on a formula in here, v square minus u square is equals to 2as. What is the maximum velocity? That's 60 meter per second. Maximum velocity means nothing can exceed that one. Okay, no velocity can exceed this one. This is the maximum velocity. So this is the final one, means now this is the initial one. Okay, now this is the no this is the final, this is the final one. This is the Vmax is the initial one. Okay, Vmax is the initial one, 60 square, Vmax is the initial one, 60 square minus 30 square is equals to 2 into minus 1 into s. From here we will find out that it comes to be 2700 3600 minus 900, that's equal to 2700 divided by 2, which will come to 1350 meters. On summing up with that 900 meters, S1 and S2, it is coming out to be 1350 plus 900, that is equivalent to 2250 meters. That's equivalent to 2.25 kilometers. This much distance the train would have covered if the velocity would have been 30 meters per second instead of the maximum velocity. This is the answer for the third part. Okay, hope you have understood this video, means this sum, and subscribe the channel for more such videos like this.